The final part of this evaluation based on pressure measurement and camshaft crankshaft evaluation, I've made the statement that I know electronically where the cam and crank are, but I cannot predict where the engine is because we don't know of the mechanical arrangement between the sprockets and the sensors and where the engine is in terms of the 4 strokes. Why don't we overlay the one way of proving exactly where the engine is in terms of physical contribution by bringing pressure back in? I've deliberately turned it off. So let's turn pressure back on, run the vehicle, gather the data. I'm going to select a little bit more data than that, start the engine, and then let's see where this leaves us. I want to ensure of a complete cycle, which we certainly have there, so I think of enough data there. Right, now it's getting interesting, because we know where it is electronically and we know where it is physically now. You can see why now I've changed the 4th channel to black. It's a much stronger colour. And what I really want to do now is overlay these 2 events, well, 3 events. We want to pick one complete cycle, so I'm going to draw a box around 2 compression events. There's your 720 degrees. Let's move this little box out of the way. Let's bring the cursors back in, the more the merrier. So let's now we do know exactly where the 4 cyclic events are, because they're based on compression and not on the theoretical position of the cam and crank sensor. So basically I've now converted time into angular measurement. Let's get rid of that box. So basically we know TDC is at the top of compression. We know it's a 4-stroke cycle, so we know this is the top of the exhaust stroke, and we know this is the 2nd compression event. So you can see now that these 2 events here are totally theoretical positions known by the ECU, but not relevant to the physical position of the engine. However, we can now make some very accurate assessments of exactly where the engine is physically against electronically. Now, providing we can access valve open close timing data, based on the description I offered before, we can now, with a greater degree of accuracy, predict exactly where a valve open and closes relative to this position. So let me try and demonstrate that. There is a degree of error, of course, in this, but it's a much more diminished degree of error, which I'm all in favour of. Now, I made the point here, I need to go back because we've lost some of the, I made the point here that the pressure started to increase. This is the exhaust stroke here, the piston's going up here on the exhaust. That the pressure started to rise before the piston got to the bottom, and I suggested that was because of the higher pressure in the exhaust stream, therefore the exhaust valve must have opened. So we now know where the exhaust valve opened, and it opened at about that point there. You can see there is, as I say, a degree of estimation. I'll try and do this accurately. About there. Now I've also, I beg your pardon, I've gone too far. I also have done some homework and worked out how many of these events there are per rotation. There are 60. So I reckon each of these events represents 6 degrees. Now then, So from this, we know TDC is here, and we know that each of those is 6 degrees. So I can now fairly accurately say that exhaust valve is just started to open at about 6 degrees before bottom dead centre. I've now overlaid the electronic functionality with the physical functionality of the engine. So, but you know what, this really does depend still on whether we're measuring all the camshafts. In this case we're not, there's only one camshaft sensor, so we still don't really know where the exhaust cam is, but we do know where its functional effect is in relation to the crankshaft sensor. We have a relationship between a functional effect in the 4-stroke cycle and the electronic position of the sensor. So we now can start to predict with a great deal more accuracy that the function of the engine electronically overlaid with its physical function in terms of pressure in the cylinder. And I'm much more comfortable with that. I was tortured in part 1 of the Pico filming we did some time ago, last year. I was tortured with the amount of inaccuracy of trying to assess engine position just based on electronics. I still have a degree of problems with that, but I put some thought into this. Now, of course, the shape of this is infinitely variable depending on the type of engine we're dealing with, camshaft design, timing, cylinder design. It's totally varies from one engine type to another. It's absolutely crucial that you compare this with the Pico waveform library to establish a known good value, or get hold of a donor vehicle and compare the value with it. But please, having gone through these 5 or so tests that we've done during this module, I hope you now accept the fact that there is no such thing as vacuum. It is pressure differential, and with differential becomes flow of air, flow of fluid. And it's the importance that the pressure differential does help us understand what's happening in the cylinder, and of course that is governed by Boyle's law. And I hope you found my explanation, it's a very personal one, I know that, but my explanation of interpretation of electronic data relating to mechanical functionality of the engine. Thank you, and I hope to see you with our next Pico presentation.